Hi, to write a solution for quicksort in JavaScript, the first thing we could do is to determine our pivot value. Pivot value can be any elements that are inside our given array. But we will we will use the value that are pointed by our middle index. So the middle index can be obtained by using the first index plus the end index and divide by 2. So 0 plus 9 divided by 2 will be equals to 4.5. So the 4.5 we will use matplotlib and wrap it so we can get the closest integer that are smaller than 4.5, which is 4. So our value will be 5. So then we will make the array into 3 symbols. The elements that are bigger than p are the elements that are equals to p, and the elements that are smaller than p. And we will declare 2 anchors from start to end, and we will move the 2 anchors towards each other until they cross each other. So for instance, L is looking for values that are bigger or equals to P, and R is looking for values that are smaller or equals to P. So X bigger, X smaller, so the two values swap. X, big X, and then we move on, and L is still going to look for big X, and R stop at P, so they swap. L is still going to look for elements that are smaller, that are bigger or equals to P, and R stay put because it's pointing to the right elements. So these two get swapped. Then the two meet. Until this point, we know that our array is already close to be sorted because the point that they meet, meaning that all the elements have already been pointed to for at least once during the iteration, and the smaller x and big X should be swapped based on this point. But we will move on to our algorithm because this is a computer. We cannot just break it here. So R is going to be looking for the next value. So in this case, R is pointing to this position, and L is pointing to this position. And we have met the requirement where L and R have crossed. So then we can start our iteration here. So from the position, by the end of this, from position 0 to R, obviously our array will be sorted into elements that are smaller or equals to P. From position L to N, our array will be sorted to elements that are either bigger or equals to P. And we are going to apply the same algorithm to these two arrays as well. For example, so this is going to be transferred into another set of smaller x, pivot value, and big X. But in this instance, there isn't one. So it will end and look like this. Because L is by the end of it, L is pointing to the last position. That means we know that from L to N is only L itself. So inside that input array at this position, 5 is fixed and it will not be changed. Then we know this element is already sorted. So we will just ignore it and run the same algorithm to the left to what's left of them. All right, another example would be using our algorithm to sort a 2-1 scenario. So our pivot value here will be equals to big X. So in this instance, nothing is changed. L is still going to look for values that are bigger or equals to P value. R is still going to look for values that are smaller or equals to P value, which is smaller X. So these two will get swapped. L gets incremented, R gets decreased. And by the end of it, from 0 to R, it only has one value. From L to the N, it's only have the value that point by L itself. So we know that there's no more elements to be sorted on each side. So we just stop our algorithms. One thing to note is that by the time the L and R meet, obviously the array is sorted. So we can actually just use one element here to determine what's left of them in real life scenarios. So our L will be returned as the new pivot point to determine, which the breakpoint of what's left of the two arrays and to be sorted. To put that into code, the first thing we do is to write a function called quicksort. And we pass in an input array, a left indexed and a right indexed. Then we always start to check the length of the array and make sure it has at least two elements inside, otherwise we return the input array. Then we determine our left, so constant left should be equals to the left indexed, or if it's undefined, meaning this is layer 1, then we will just use 0, position 0. We do the same to right. Position input array the length, so the index will point to the last element of the given array. Then we use our pivot. Pivot is going to be left of the result array, like we just discussed. So we will first write a function called quick sort left and the right, and we will have it return our left in the end. So it's going to take in left and take in right anchor and use our input array here. So let's write our function, quick sort left and right, taking input array, taking left, taking right. And here we can determine our made point. Made point can be get from use mass floor, and we pass in left plus right divided by 2 right, but we can actually write it like this. So we don't add left and right directly, and we use this workaround because left and right could be getting pretty large down to the road. So if the value gets larger, we could there might be problems in C language. But in this case, it's best practice to just use it. It's best practice. And then we can know what's our pivot value. So our pivot value will be equals to the input array at the index of main point, right? Then we can start do our comparing. So well, left is still on the left hand side of right or equals to the right hand side. We do our sorting. We first find the right position for the left to point to. So it's going to be input array left, where it's still smaller than the pivot value. We move on. Well, right anchor points to a value are still bigger than the pivot value. We move on. And once the two position stops, we could check if left is still smaller or equals to right. If it's still smaller or equals to the right, we could swap them. Sure. So it's we use a common practice here. Declare temp still bound of the value inside. Then we do swap. Then we put what we stored earlier inside the right input array. Then after the swap, first we can first point our anchor and make them move on, right? So okay, by the end of this while loop, I think our array will be sorted into big X and P and smaller X and P. So let's return our left as our pivot, new pivot. So after the left gets pointed to the new pivot, we could check if our original left value is smaller than our pivot value -1. So it's going to be R, right? And so if it's smaller means there are more elements inside to sort. So we just pass in the input array, and yeah, we use left 0 in this case, and we use pivot -1 here. If our right are bigger than pivot, so it means here from left to end, we will use quick sort input array dot. Okay, it's going to be starting from pivot to the end elements, and that's going to be right here. Yeah, I think our array will be sorted by the end of this, so we return our input array in here. Yeah, what's left to do is to console log the solution. So we console log, we put in the quick sort, we invoke the function, we pass in the unsorted array, then we run now. So as you can see from here, our array is finally being sorted by quicksort. And this function is also going to work on elements like 0 and small, negative values. So as you can see, again, our array is being sorted. So this is typically how you write a quicksort solution in JavaScript. Thank you for watching.